Hi everyone, this video is episode number 2 from my data structures and algorithms tutorial series. My name is Shaheen, and in this channel I create content related to software engineering. So if you're into this stuff, you should definitely consider subscribing. In the last episode, I talked about data structures and why you need to have a thorough understanding of data structures to write fast and elegant code. So if you missed that video and you want to go check that out, there should be a link in the top right corner of this video. So without further ado, the purpose of this video is to understand algorithms and why we should learn algorithms. So let's start by asking the question, what is an algorithm? An algorithm is simply a set of instructions to complete a specific task. So for example, there's an algorithm for getting ready to go to work. There's an algorithm to drive your car. There's an algorithm to prepare some lunch. Essentially, the specific steps you take to accomplish a task is an algorithm. All right, so now you know what an algorithm is, but why is it important to learn? You already know from the previous episode that choosing the right data structures can have a great impact on how fast your code runs. But there's another major factor that affects the efficiency of your code, which is selecting the right algorithm for your programs to do their task. To really understand this better, let's look at an example using the array data structure. Here you see two types of arrays, the standard array and an ordered array. And you already know that an array is simply a list of data elements. The main difference between a standard array and an ordered array, as you can pretty much guess, is that in an ordered array, the elements must be kept in order. So that means when it comes to inserting a new element for a standard array, you can insert a new element at the end of the array or at a specific index that you provide. But this is not necessarily the case for an ordered array. In an ordered array, the computer first has to search through the array to find the right index before the insertion can occur. So when it comes to insertion, the computer would have to do more work for an ordered array than it would for a standard array. This might make you think that an ordered array is not as efficient as a standard array, but this is not always the case. Yes, it's true that an ordered array is slower when it comes to insertion, but what about when it comes to searching? In the previous episode, we looked at searching through a standard array where for an array of size n, it takes the computer n steps to complete the search, since the computer potentially has to search through all the elements in the array one at a time. But what about for an ordered array? Let's go through an example where we search for the value 75. In the standard array, the value 75 doesn't even exist, but the computer would have to go through all the elements in the array before it can conclude that. In the ordered array, the value 75 also doesn't exist, but the computer doesn't have to go through all the elements in the array to determine that. Why? Because when the computer finds the value 82, it can stop the searching right away. Since it's an ordered array and the computer already found a value greater than 75, it can already conclude that 75 doesn't exist, so it doesn't have any need to search any further down the array. So far with this example, for both standard and ordered arrays, we're instructing the computer to search through each element one at a time. This algorithm is known as linear search. With the standard array, when we perform linear search for a value that doesn't exist, or when the value happens to be the last element in the array, the computer has no choice but to search through all the elements in the array. With the ordered array, we also performed linear search, but we were able to improve the algorithm just a little bit, where the computer can at least stop searching earlier if it happens to find a value that is greater than the value we're looking for. We're about to see the power of learning and applying algorithms. Up until now, we assumed that the only way to perform search was for the computer to go through each element in the array, and this made sense for a standard array. However, when it comes to an ordered array, we have another choice, an algorithm called binary search, and we'll see very soon that binary search is much faster than linear search. I plan on dedicating a separate video altogether for binary search, and for the purposes of this video, walking through binary search at a high level is sufficient enough for you to understand the importance of algorithms. Let's see how we can search an ordered array using the binary search algorithm, and this time let's search for the value 37. With binary search, we start taking guesses on where the value might be, and we start guessing from the middle of the array. Since there are 10 elements, there is no exact middle, but we can be close enough by selecting index 4 as our first guess. At index 4, we find the value 48, and it's not a match. Also, we see that the value 48 is greater than the value we're searching for. So right away, we can choose not to search any element to the right side of 48 because all of those elements will also be greater than 37. In a single step, we've basically eliminated half of the search criteria. Now we can just focus on the left side of 48. So we repeat the process of guessing a number in the middle. This time in the middle, it's the value 16, which is also not a match. 16 is smaller than what we're searching for, so we can eliminate 16 and every element to the left of 16, and so now we're just left with 2 elements on the right to focus on. So next, our guess ends up being 24, which is not a match. And then finally, we have one last element to inspect. If in the last element we don't find a match, then the value we're looking for doesn't exist. But in this case, the last element is 37 and we found a match. So using binary search, we're able to complete our search in just 4 steps. But for this example, using linear search, it would have taken 4 steps as well to find 37 if searching one cell at a time from the left. However, if instead of 37, if we happen to be searching for 99 or a value that doesn't exist in the array, then linear search would have taken 10 steps and binary search would still just require 4 steps to complete. Now let's look at the opposite. If we're searching for the value 3, then linear search would actually be faster than binary search because it would complete in a single step versus 4 steps as it would with binary search. Wait a second, didn't I say before that binary search is much faster than linear search? Well, the fact is, for small-sized arrays, binary search is not really all that efficient than linear search. But let's see what happens when we start to search in larger-sized arrays. If the array size is 100, in worst-case scenario, linear search would take 100 steps, but with binary search, it would just take 7 steps. With an array of 10,000 elements, linear search may potentially take 10,000 steps, but with binary search, it would just take 13 steps to complete. And with an array of 1 million elements, linear search can potentially take 1,000,000 steps to complete, but binary search can do it in just 20 steps. And this makes sense because with binary search, we're able to cut our search criteria in half with every step. Now you should be able to see the power and importance of algorithms for writing fast and efficient code. In this episode, you'll learn that algorithms are just instructions for completing a specific task, and that along with data structures, choosing the right algorithm plays a major role when it comes to writing fast and efficient code. We went through an example of searching through an ordered array to understand the importance of algorithms. Then we peeked into a new algorithm called binary search as an alternative to linear search and saw that for large-sized arrays, binary search is much more efficient than linear search. And with that, let's conclude this episode here. If you found this video helpful, please like and subscribe for the YouTube algorithm, and I hope to see you in the next one.